Hello and welcome back to our channel, Planetarium, where we uncover the mysteries beyond Earth. In today's video, we're going to talk about a subject that has long fascinated scientists and the public alike: black holes. Black holes have been shrouded in mystery for years, and we've never entirely understood them. However, recent scientific discoveries have shed some light on what's inside a black hole, and it might just change everything we thought we knew. Black holes are incredibly powerful entities in the universe, a mixture of space-time and matter all wrapped up in a single point. They can absorb anything that comes into contact with them. While we know they're extremely powerful, we haven't known many of the specifics behind them. Well, until now. Scientists have been studying black holes for decades, and they have finally figured out the inner workings of one. But before we dive into the current discovery, let's start with some background. What are black holes? Most of us grew up knowing that black holes were real, but there was a time when they were just a theory. It wasn't until the late 1960s that the first black hole was discovered, known as Cygnus X1. From this discovery, scientists gained some insight into how black holes work and behave. For instance, they found that a black hole is an incredibly dense area of space-time with such immense gravity that nothing, not even light, can escape from it. They also discovered that black holes come in different sizes, with the biggest ones being around 200 kilometers across. The smallest ones are tiny, about the size of an atom. Cygnus X1 is a stellar mass black hole, which means it's only 6 times bigger than our Sun, but has the same mass. The discovery of Cygnus X1 also revealed that black holes tend to have strong magnetic fields and a powerful gravitational pull. This makes them incredibly dangerous and can cause serious destruction in the universe if left unchecked. This discovery enabled researchers to learn more about how these powerful cosmic objects work and to develop theories that allow us to understand these mysterious phenomena better. From this discovery, we also found out how rare black holes actually are. It turns out that there may be close to over 1 million in the Milky Way alone, yet they're still incredibly hard to detect, leading many to speculate that the actual number could be significantly higher. If there are that many in our galaxy, we need to learn more about them, and thus began the journey to really understand what's inside a black hole. In essence, when something enters a black hole, it is trapped and compressed down astronomically until it reaches a singularity, the main mass point of this entity where all matter is essentially crushed into one single particle. But before reaching this point, there are 2 layers of the black hole that one must travel through in order to reach this singularity. The first layer is known as the outer event horizon, a boundary surrounding the mouth of each black hole where anything entering it will not be able to escape due to its incredibly strong gravitational pull. This layer is responsible for trapping and slowing down anything that falls into it, so much so that to escape it would require traveling faster than the speed of light, an impossibility at this time in our current understanding of physics. This is also the point where the physics of our universe stops working, replaced instead by a new set of chaotic laws that govern what goes on inside. The second layer is known as the inner event horizon, which acts as a gateway leading towards the singularity. This is where the real danger lies, as once a particle enters this layer, it has no chance of surviving or escaping, and is almost certain to be crushed into a single point of matter. At this point, gravity is so powerful that it bends even light itself, while time slows down and temperatures become unimaginably hot. So not only is matter being crushed, it's being boiled alive. What makes black holes so dangerous is that they all have completely different gravitational pulls, making them incredibly difficult to study and predict due to their unpredictable nature. The thing that makes them even worse is that due to the incredibly strong gravitational pull within and around a black hole, it is impossible to observe them directly. So scientists have to rely on observations of stars that orbit nearby these entities in order to gain any meaningful information about what lies inside them. Think of it this way: you've got this overwhelmingly powerful thing in space that you need to know about, but the thing exists in 3D, while we can really only study it through telescopes and pictures, or 2D, without ever going inside. Because as we've established, once you go in, there's no coming out. But that's not all. The problems with studying black holes stem from a fundamental impossibility. we can't travel fast enough to escape their gravitational pull. This means that scientists are essentially limited to studying them from afar, which is challenging, given the sheer size and complexity of these phenomena. In order to do so, they have to observe the radiation the black holes emit and the dust and gas that surrounds them. This makes it incredibly difficult to create a detailed image of what's inside the black hole, as any probes or cameras sent out into space would be instantly crushed by the event horizon once they reach it. Further complicating matters is the fact that every black hole is unique in its own way, meaning that there's no single standard model for how they form and behave. On top of this, physicists have so far been unable to make sense of the singularity that lies at the center of all black holes, as we simply don't possess the technology to travel fast enough to reach it. This means that all we can do is theorize about what might lie within, but nobody will ever truly know until we find a way to transcend the boundaries of space-time and travel faster than light. Despite the danger and mystery surrounding these massive astronomical phenomena, they can still be studied and understood to an extent. By mapping out stars that are close enough to the event horizons of black holes, scientists are able to observe them from afar and gain valuable insight into their structure and behavior. This knowledge has allowed us to further explore space safely and develop theories about what lies beyond the event horizons of these mysterious entities. As scientists have done just that, there have been particular theories that have come up and, well, this is where things get really interesting. One theory about black holes suggests that they are not just huge masses of nothingness, but instead could be gates to other galaxies and universes. This idea is based on the movie Interstellar, where characters travel through a black hole in order to find a new home for humanity. If this theory holds true, black holes could provide a gateway to faster-than-light travel. This would mean that we could navigate through them to reach galaxies and universes beyond our own, not limited by space and time constraints. However, this theory is still very much theoretical, since it relies on creating technology that can travel faster than light. That's not all. There are also other problems. For instance, due to the gravitational pull of a black hole, any spacecraft entering it would become trapped and unable to escape again. This means that traveling through them would require extensive research in order to avoid such a catastrophic event. In addition, the immense radiation that comes with black holes could also be dangerous to any spacecraft traveling through them. Plus, it is still unknown what else may lie beyond the singularity of a black hole. But the thing is, scientists are already working on creating a spacecraft that can travel faster than light. If they're able to create this spacecraft, chances are black holes might just be one of the first things we look more into. While there is enough proof that holograms are in fact real things, as we've discussed earlier in the video, studying these mysterious beasts of energies is extremely difficult. So, Enrique Rinaldi set out to simplify the entire concept. He wanted to approach things totally different, and he did so by taking two of the most common theories about black holes, particles and gravity. When combined, they're known as quantum matrix models. Rinaldi then went even further and proposed a new theoretical concept, which is now known as holographic duality. This theory suggests that when we observe a black hole in space, it should be viewed as a hologram. The essence of this theory lies in the idea that the outer space around a black hole plays an important role in its function. It is not just a singular point where all matter compresses, but instead is part of an ongoing cycle of energy. According to Rinaldi, the particles and gases found in outer space provide the fuel that powers a black hole. In other words, when we look at a black hole in the form of a hologram, we can see how all of these elements interact with each other and come together to create something new. This is a much different picture than what has previously been suggested about the behavior of black holes. So instead of a singular point where all matter compresses, we should be looking at the possibility of a moving black hole. The idea is that it is constantly consuming dust particles and gases from its surrounding space, which helps to power it further. This means that even if a black hole were to move near a planet, it could still consume its matter and continue growing in size. The implications of this new theory are exciting, as they could lead to the development of a better understanding of black holes and their behavior. If we were able to unlock the secrets that lie within these mysterious objects, we might even be able to use their energy for our own purposes. It's still uncertain whether this theory is correct, but it provides a much more exciting look at these powerful objects. As technology advances and we continue to learn more about black holes, the possibility of unlocking new secrets remains open. Only time will tell what discoveries lie in store. But from what we've already learned about the inner workings of a black hole, chances are that things are just going to get increasingly more interesting. And, well, when they do, we'll be the first ones to talk about it here. And on that note, we'll wrap up today's video. What is your theory about black holes? Let us know in the comments below. If you like this video, please give it a thumbs up and subscribe to our channel for more videos just like this. And we'll see you in the next one.